Okay, let's continue. Hi, my name is Henry. Welcome to today's online presentation for midas GTS. Today I will talk about the 2D parametric study of the parallel tunnel system. Okay, so for the parametric study for tunnels, today we are going to show you how to perform this study, and we will show how easily the user interface of midas GTS. It's very easy for modeling and do the meshing, and it's also very easy to define the construction stage with just drag and drop of all the activities. And in this one parametric study fields, we can cover all multiple cases for different rock conditions. I will mention about that more later. So for the and also after the finite element analysis, the results can be easily viewed and extracted. And also it's a full solution for 2D and 3D geotech work. And in the end, I will show you one project application of midas GTS. Okay, here's the two tunnels we are going to do the parametric study today. We have two parallel tunnels as you can see here. We will do the construction from the left one to the right one. Okay, so as we know, parametric study is the first step for the tunnel design and analysis. So when we start the design of tunnels, we want to know and we want to estimate the behavior of the tunnels under different K-naught conditions of the rock. So as we know, K-naught is the initial stress parameters of the rock. It's not very easy to get it from field tests or lab tests. So that's why we want to use finite element software like GTS to model these critical conditions. So what we do is we assume different K-naught values to simulate different rock conditions. And in GTS, we do not need to run different models for every K-naught values. We just need one field. As I just mentioned, we can assign all the K-naught values in the parametric study. And the program will just automatically generate the results for each K-naught cases. That's why we show this here. We analyze the different multiple conditions all together. So here's the steps we are going through today for the parametric study. First, we will import the geometry and the element properties in the program. And then we do the mesh and extract some of the elements for different materials. Then we assign the boundary conditions, we assign the loading conditions, and then we define two cases. One is the construction stage cases, another one is the parametric study cases. Then we will do the analysis and show the results. Okay, again, here's the overview of the two tunnels under the rock. So in the next page, you can see all the materials will be used today. You can see we have 4 different rock conditions. And the difference is we assign different K-naught values for them. The K-naught values will range from 0.5 to 2. Okay, so in this page we can see we have two types of shotcrete materials. The reason is that when we first apply the shotcrete on the internal surfaces, it will be soft, but due to the hardening over time, the materials will turn into hard shotcrete. That's why we have two different materials here. Okay, so now we are going to the software. Okay, I will first create a new project. And as you can see here, in the project setting window, you can give a name for this model file, and you can choose 2D or 3D. In these cases, we will pick 2D. And then in the analysis constraint, we will choose X and Y plane, and the gravity is of course in Y direction. And all the values are here. And by the way, we can also define the units for this model. In these cases, we will use kips and feet. Let me click OK. And by the way, down here in the right corner, you can also change the units anytime you want, and the system will automatically update all the units we have already defined. So now you can see the GUI, the user interface of the program. On the left side is the model tree. Here you can check almost everything you have already defined here, like geometry, mesh, and properties, and also the analysis. Once you have already, if you select one, if there's something here, for example, we go to geometry, and all the information associated with this one will be shown here in the property windows. And here's the work window. We do all the modeling and the mesh. And down here is the output windows. You can see all the messages during the analysis and design. And also here's all the shortcuts of the features of the midas GTS. Once you are fluent with the software, you do not need to go to each menu to select anything. Basically, almost everything you want to use can be found here. Okay, so now we will first import the geometry. So we go to File, Import, and you can also see here we can import different kind of geometry from different sources. So in this model, we will import it from a previous defined geometry. Let's open that. So as you can see here, we already imported the geometry. And another thing is, when we do the modeling in this modeling window, we can just easily use our mouse, like the scroll, to zoom in and zoom out. And when we hold Control key and the middle bottom of the mouse, you can easily move it left and right and all around. And also by just hold on the middle button of the mouse, you can rotate it when you do the 3D modeling. It's very easy for you to use. Now let's go back to this 2D view. Okay, now as you can see, we already have the geometry here. The next step, we will import we can define the materials and attributes. So we can go to Model, Property, and Attributes. So the attributes in midas GTS is the materials property and the section property. So for example, we want to add the route conditions. So we click Add, Plane. So here we can give the ID number and the name. And for the materials, we can also define that. So it's another window for the materials. We can also do add like ground. So here we can define the route conditions here. We can give a name, and we can change all the parameters values for the materials parameters. And of course, in this case, the most important here is to define the K-naught value. And also, we can also define the thermal parameters, the seepage parameters, and the drainage parameters. Of course, we are not going to use them here in this model. And also, in this constitutive model, for the model type, we have a lot of choices, as you can see here. So today we are going to only use more column. Okay. And in GTS we have a function called import. For example, if we already have some other projects and we have already defined a lot of materials, for example like log, shotcrete, or logbow, we can just reuse them here in this model. We do not need to redefine them time and time again. So we can just go to import the materials attributes from previous projects. Okay, here's the window, and we can pick the attributes we want to use. In this case, we want to use them all, so it's like all. And another thing is, if you want to do some changes for like previously defined attributes, you can also do all the changes here as you like. Okay, now we have finished defining the materials. We can check them in the work tree. Okay, as you can see here in the attributes here and materials here, you can check all the materials properties. And all the property will be shown here down in the property window. Okay, the next step we are going to do the mesh. We can go to mesh, auto mesh, planar area. We want to do the mesh for the two tunnels, left tunnel and right tunnel. So let's zoom in. We can select the edge. And here, as you can, okay, by the way, I need to change the unit, as I just said, to kips and feet. Okay, we do the mesh. We select the tunnels. And here for the element size, we'll give it to 3.3 feet. And for the attribute, we pick rock k0 equals 0.5 conditions. And we give a name to be left tunnel. And for the advanced option, as you can see here, we have three types of measure. In this case, we choose loop measure because it is ideally for the rounded or circular geometry. And we choose triangular. Okay. And we can do the preview, see all the seeds around the tunnel profile. We choose apply. Okay, and then we do the same for the right one. Change the name to be right. And this option is same. Let's preview and apply. And then we want to do the mesh for the whole rock. So we select edges. And also the edges of the tunnel profile. This time the element size, we will choose 23 feet. And the attribute will stay same as k0 equals 0.5. And we give a name to be rock. And this time for the advanced option, we will choose Delaunay measure here. Okay, now let's first zoom out so we can see the whole view. Let's preview, you can see the seeds and apply. Now you can see just outside the edges of this geometry, the mesh size is bigger, but around the tunnel, the mesh size is really small because the stress concentration is larger. So the smaller the mesh is very small. So after we do the finite element analysis, the results will be more accurate. Okay. Now we also want to do the mesh for the rock boat. Let's go to the mesh, auto mesh. This time we pick edge. Okay, we want to select the edge of the rock boat. As you can see here, because we are already done with the mesh of the whole rock, it's really hard to just select one of the rock boat. So you can just directly go to the window here and turn off the mesh, so we can easily select the rock boat. And here we can also use this function, select function, called the included intersection, sected. So we can just easily pick the rock boat. This time the number of divisions we choose 1, and the attribute we choose we choose rock boat. We give the name as left rock boat. Okay, then we do the preview, and we do the same thing for the right one. So we just change the name to be right rock boat. Preview. Okay. Then we want to extract the element for the tunnel profile of this shotcrete. So we can go to Model, Element, extract element. So we choose edge when we select the turn-on profile, and we assign the attribute to be soft shotcrete and apply. Then we do the same for the right one to be attribute same as soft shotcrete, and change the name to be right one to be right shotcrete. Okay, as you can see, I forget to give the name to the left one. We can just easily go to here and press F2 to change the name to be left shotcrete. Then next, we want to define the boundary conditions for the whole turn-on. So we can go to model, boundary, and ground support. By the way, here we can also do the boundary set. And if we do that, we want to assign the different boundary conditions for the 3 edges here. But in the program, as we already defined the XY plane and the gravity direction to be Y direction, so we can just easily use ground support. And the program will automatically generate the boundary conditions as in the real situations. So we choose ground support. We give the name as ground support. When we want to select all the mesh, as we already turned off the mesh, we can turn them on back again. So we select all the meshes. Okay, and apply. Now we can see the boundary conditions is shown here. Okay, now we want to change the element attribute for the shotcrete. As I just mentioned, due to the time and the shotcrete will be cured, and the material will turn from soft shotcrete to be hard shotcrete. So we can go to boundary and change element attribute. Again, we want to turn off the mesh so we can easily select the materials, the geometry we want. Okay, let's zoom in. And this time we give the name as left hardening. So we select the turn-on. Okay, so now I want to select the turn-on. Okay, so this time we give the attribute to be hard shotcrete and apply. And then we do the same for the right one. We change the name to be right hardening. We select them and apply. So now we can define the self-weight of the turn-ons. Let's go to model, load, and self-weight. So we give a name as self-weight and the factor in y direction -1 and apply. So now we can continue to define the construction stage. We go to model, construction stage, define construction stage. So to have a better view, I want to move this model on the right so you can see any changes when we define the construction stage. We first click new. Okay, we want to turn it on so we can easily view everything here, and we check on the activated. So for this new, we can choose a construction stage. For the first construction stage, we want to use a left terminal, right terminal, and the rock, and also assign all the load conditions and this boundary support. So here we want to check on the clear displacement. The reason we want to use clear displacement is we want the system to define the initial condition of the rock strata. So all the displacement will be computed begin from this initial stage. So we click save, and for new one, click save. So from the third step, we will start the excavation of the left terminal. So we will deactivate the left terminal. We can just drag it the left terminal here. Okay, my bad. We should go to left terminal, not right. Okay, as you can see, the left terminal has been excavated. So this time we will check on the LDF. So LDF is a load distribution factor. So this is after the excavation, how the loads are to be distributed in the neighboring rock strata over the subsequent construction stage. So for the current stage, as you can see here, only 40% of the load will be distributed, and in the next two construction stages, 30% will be distributed. Okay, go to save. And for the next one, we will start, once we finish the excavation of the tunnel, we want to apply the materials like the rock bolt and the soft shotcrete. So we will activate them. So we'll go save. And for the next one, after the materials has been applied, as I just mentioned, due to the time and the materials will be cured and will become hardening. So we will activate the left hardening. Save it. And then we will do almost the same thing for the right terminal. Click new. First we start the excavation of the right terminal. As you can see here. Check on the load distribution factor. Save. And for the next one, we apply the materials. Then for the last one, it will be hardening. Okay, now we have already defined the construction stage. Next we will define the analysis case. So we go to analysis case. So we can add a new analysis case. We give it a name, as we want to use k now equals 0.5. So here we can choose construction stage. Also we have other options when we do other kind of analysis cases. Here we use construction stage. And for the analysis control, we will check on the initial stage for stress analysis, and also k-naught conditions. Okay, so as you can see here, we already created one analysis case for k-naught equals 0.5. So next, we will define the parametric study cases. We go to analysis, parametric study. So here we can give the name to be k equals 1.0. So the base analysis case will be, we already defined k equals 0.5. Here, as the k-naught value is assigned to the rock and the left and right terminals. So we will check them out. And put them here. So in this parametric study, we assign different k-naught values. So we want to be the target to be k-naught Sorry guys, we have some problem when we transfer this window to different screens. So now we can see we already defined in the parametric study, we defined these three cases. In this program, we just want the k-naught to be changed and everything stays the same. So once we have already defined the three k-naught conditions, the program will automatically do all the parametric study for these four k-naught values altogether. Okay. So now we can go to the analysis. We go to analysis and solve, and we check on all the cases we have already defined, and okay. So during the analysis, I want to show our contact information. So if you have any questions, just feel free to email us at midasoft@midasuser.com. And you can also go to our website at midasuser.com. And if you have any questions, you can also type in your questions in the chat window. And if we cannot answer all of them, we can get back to you after we finish the webinar. Okay. Okay, as you can see, the analysis is being done, and all the messages are showing here. What is generated here. Okay, now we have finished the analysis. We can check the result. In the work tray, we go to post, and you can see all the results are showing here in this menu. Let's first check k-naught equals 0.5. So we want to check the displacement in the last stage. We go to displacement for the xy direction. As you can see here, here's the contour diagram showing the results. And here's the maximum displacement here. So better to view it in the inches. So as you can see here, let me turn it to a better view. Okay, so the maximum displacement is 0.156 inches. And we can also check the different construction stages. So let's see different construction stages. So this is the first construction stage, second one, third one. We start the excavation of the left tunnel, and then go to the right one. Okay, and we can also check the other k-naught conditions. For example, k-naught equals 1.0. The results will be like this. The maximum displacement will be 0.146. And k-naught equals 1.5. The maximum displacement will be 0.2 inches. And the last one. Okay, and also for each other k-naught conditions, you can also view the construction stage. Okay, let me just show it here. And also we want to see the stresses. So let's go to 1D element stresses. We go to XX. So let me zoom in. So now you can see the diagram show the stresses along the rock bolt and the internal edges. Also, we can also view the results in the tabular format. We just click table. So we can select whatever we want to show in the table. So we just click OK. And here's the tabular results format. We can also use sort function to see the maximum values. So we just click sort. Yeah, we can make it like the first priority. You can go to sort. Now you can see the maximum compression stresses is here, shown as here. And we have another function to export the table into Excel file, so it can be very easily to use in your report and the analysis results. Okay, now we have finished the demonstration for the parametric study. In the end, I will just show you our project application. Okay, so we finished the parametric study for internals. I think we have already seen the parametric study and the user-friendly interface of our program, and how we define the construction stage, how this one parametric study file can cover multiple K-naught cases, and the results can be easily viewed in the tabular format and the diagram format. And then I will show you just one quick project application. So here's a project done by Parsons and Brankerhoff. The location, as you can see in the next map, the location is just here in downtown New York City. So what they do is they do two types of analysis. They want to monitor the initial support capacity, including the rock bolts and the shotcrete of the tunnels, which is similar as we just used in our demonstration. And also in the geotech level, GTS was also used to define the construction sequences for the fan plant. Okay, now we can go to the model. You can see all these 3D models were generated during the construction sequences. Okay, that's it for today's presentation. So again, if you have any questions, just feel free to send us email at midasoft@midasuser.com. And also, you can also go to our website at midasuser.com. And then if you want to have your questions to be answered right now, you can also type in your questions in the chat window.